Hi, we're going to look at this video where we're going to use the definition of the derivative to show that the derivative of f of x equals square root of x is 1 over 2 times square root of x. So some students may know some shortcut rules or may have memorized some rules to get those derivatives, and that's fine. We're all going to know them pretty soon. But the point is that all of those rules come from that definition of the derivative. So we're going to practice using that definition to show that this is the derivative, and then once we know that, we won't have to use that definition anymore. So first of all, we want to make sure that we remember what is that definition of the derivative. So hopefully you're saying to yourself, oh, it involves a limit and some h's, right? So let's go ahead and write that down. So definition of the derivative would be f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h for all values of x for which this limit exists. So I'll just write when this limit exists. All right, so that's the key to getting started on this problem, is making sure that you remember that definition. That should be something you memorize so that when you look at a problem like this, you know exactly where to start. Okay, so in order to do this problem, we're basically going to just apply this definition to the function that we have. So I'm going to start by just rewriting that definition over here. When you're doing a problem like this on a test or a quiz or anything you're turning into your teacher, it's a good thing to just write this down to start with. Let them know you know at least how to begin the problem, right? Okay, don't forget that limit. That's an important part of this. Sometimes I see students forget that. Okay, and then we want to do what this definition says to that function that we're working on. All right, so it's important that I write that LIM on every single step, right? That's an important part until I get to the end where I've evaluated the limit. Okay, so we have f of x plus h, so that means we're going to put the x plus h into our function in place of x, so into our function. So we'll have square root of the entire x plus h, then minus f of x, that's just the function, the original function, all over h. All right, now we just need to evaluate this limit. So we have a lot of tools for evaluating limits. We have a lot of theorems about how to evaluate limits. So we might first think about if we could do a substitution shortcut theorem. Unfortunately, you should recognize pretty immediately that's not going to work. I've got this denominator that involves h, and we're considering a limit as h approaches 0, so that's not going to work. All right, but we did some problems like this when we did limits, where we had radicals, radical expressions, and we had a little algebra trick that we used a lot to help figure out how to get the eventual answer to the limit. So we rationalized the numerator. We're going to use that same trick again. So we're going to multiply by the other factor from a difference of squares here. So we would have square root of x plus h plus square root of x. And then, of course, if we multiply the numerator by something, we have to multiply the denominator by the same thing. Okay, and so while that looks a little more complicated to start with, we know from the problems we did before that if we just kind of follow the steps through, we get some really nice cancellation, and we should be able to evaluate the limit at the end. So let's see what happens when we do that. All right, so limit as h approaches 0. So when we FOIL out these two factors here, we're going to have square root of x plus h times itself. So that'll just leave x plus h. Square root of something squared. The square and square root will end to each other. And then we will have a plus square root of x times square root of x plus h, and then a minus square root of x times square root of x plus h. So the plus term and the minus term, those will cancel each other out. And then minus square root of x times square root of x will be just x. All right, we're going to leave this denominator in factored form. Remember that it's sometimes tempting to multiply that out, but then we would just have to refactor again at the end. All right, so now it's time for the fun part, all the cancellations. So we've got a couple x's that can cancel. All right, one important thing about these problems, I told you what the answer is. The statement of the problem up here says that we're supposed to get 1 over 2 square root of x at the end of the problem. So I know what the answer is supposed to be. You know what the answer is supposed to be. What I want to see when you do these problems is I want to see your work and the steps. So it's important that you don't skip too many steps as you do this. You could probably skip one of these steps I'm writing out, but pretty much all of the rest of them you should be doing. Okay, so I have one step where I canceled the x's, and then in the next step I was able to cancel these h's that are common factors of the numerator and denominator. Be careful, that leaves a 1 on the numerator after you cancel out that h. All right, so I think we've got a simple form here now that maybe we can finish the problem pretty easily. All right, so yeah, that algebra trick of multiplying by that other factor in that difference of squares allows us to get all these nice cancellations. And we now have a function here that I need to take the limit of as h approaches 0, and this, unlike what we started with, I can actually just use a substitution shortcut on. So I don't have 0 on the denominator of this function, so I can go ahead and use my substitution shortcut. And so now I'm going to have 1 over, I'm going to substitute in 0 for h. There's more than one letter here, so make sure you're putting 0 in the right place here. I'll have square root of x plus 0, so that'll just be square root of x, plus another square root of x. And square root of x plus square root of x is 2 square root of x. And hopefully we got what we were supposed to get. Yep, we sure did. So there we go. That's what we wanted to show. Got to the end. The key part here is making sure in the middle you've got all of these steps shown with the algebra shown at every step. The other important part that I want to see on all of these is this limit as h approaches 0 on every one of those steps until you evaluate that limit. All right, we're going to do another problem like this in the next video with a similar problem, but just a different function.